In example 2.1i, we'll be looking at y equals the absolute value of x. And hopefully you've seen the absolute value bars before. That's what we have here and here. It's the absolute value bars. And the absolute value bars are interested in always finding the distance a number is from 0 on the number line. So there is another way to define this using the piecewise notation. So we can define this as x if the number that you're working with is greater than or equal to 0. And then we can define it as being the opposite of x if the value that you're working with is negative. So what this basically amounts to is everything ends up mapping to something that's positive, because the absolute value is really interested in just distance from 0 on the number line. So the name for this, as you might guess, is the absolute value function. For the absolute value function, we don't typically use the piecewise definition. We will use the absolute value bars, because those are usually pretty well understood in the mathematics community. So we'll say f, and we'll say the domain is going to be all real numbers given by f of x equals the absolute value of x. And for the table, x for the first column, f of x for the second, we will have -2, -1, 0, 1, and 2. Old fan favorites there in terms of x values to choose. And then you apply the absolute value operation to each one of these. So -2 would be 2 units away from 0 on the number line. So this would be a +2. -1 is 1 unit away from 0 on the number line. And you don't really have to make a new number line to do that when you have a number line already here on the Cartesian coordinate plane. So if you look at that, that's where you can see this. So here's where -2 is located, and then you go back 2 units to get to 0. And the same idea applies to -1. 0 is already at 0. So 0 just maps to 0, 1 maps to 1, and then 2 maps to 2. Always talking about distance. Distance is thought of as a positive quantity always. So when we plot this, we're going to see a new shape, new pattern that comes out. Not that there isn't some similarity to some of the others. For example, this would sort of look like the squaring function, because you have the first and the second quadrant, and they are seemingly mirror images of each other. But it's not going to be a curve like the squaring function. This is going to be straight lines. So we're going to have one straight line in the first quadrant, and we'll have a second straight line in the second quadrant, and they will be mirror images of each other. And this ends up giving us a V shape, and this is your absolute value function.